Hey students, we are on Unit 8, Day 4. This is going to be really quick set of notes as we only have maybe 5 or 6 examples that we're going to look at. So we are looking at Unit 8, Day 4, angle of elevation and angle of depression. Now these definitions, I don't put them in your vocab, but if they showed up on a vocab test, you would be responsible for knowing them after I've taught them to you. Okay, angle of elevation. When looking up, so elevate, think an elevator has to go up before it comes down. When looking up at an object, the angle of elevation is formed by an observer's, this is important, line of sight and a horizontal line. Okay? So look at the person looking up at the top of the lighthouse. This is the person's line of sight, and then this is the horizontal line. Horizontal goes left and right. And so the angle of elevation would be the angle right here. So what I want you to get used to seeing is that the angle of elevation is always the angle that's down in this position. Here's my right angle. Barely see it right there. There's my right angle. The angle of elevation is going to be down here at the bottom of the triangle. Okay? Angle of depression. When looking down, to depress something, press it down, okay? When looking down to an object, the angle of depression is formed by the observer's line of sight and a horizontal line. So if the lifeguard is looking at the swimmer, here is his line of sight, and then here is the angle of depression. Now, we'll get to this in just a minute, but what do you notice about the angle of depression here? You don't have to highlight it unless you want to in this set of notes. Here's my triangle. Where is that angle of depression located in relationship to the triangle? It is not on the inside, it's on the outside. This is the angle of depression, okay? Because I highlighted the triangle in yellow, the right triangle in yellow. That angle of depression is from his line of sight and a horizontal line of him looking straight ahead. And if you think of it this way, if he's looking straight ahead, he has to look down to see the swimmer. And so that is the angle formed by looking from straight ahead and his eyeballs go down. Same thing right here. The person is looking straight ahead at the lighthouse and then they look up. That's where the angle is formed. Okay, now this part right here, super, super important because it's going to fix this being on the outside. It says the angle of depression is congruent. What does that mean? Equal to, is congruent to the angle of elevation because they are, remember what I told you in geometry that we never stop learning what we learned? Okay, here's another place. Alternate interior angles. Do you see the Z? Anytime we have parallel lines and the ground is going to be parallel with his horizontal line, we can draw the Z and we would have alternate interior angles. So that means, voila, the angle of depression is also located the same exact place where the angle of elevation is. And that's kind of neat. The angle of elevation and the angle of depression are actually, because they're congruent, they're the same angle. So let's put here. All right, they are the same angle. And let's draw a triangle. Make sure it's a right triangle and color that angle in. Okay, so that means in our word problems, the only time you're not going to use this angle is if it tells you something specific about this angle up here. Okay, and we'll have some of those happen. All right, so here's an example again. The dog is looking straight ahead and then he looks up at the bird. So this is the angle of elevation. The bird is looking straight ahead and the bird looks down at the dog. So this is the angle of depression. These two angles are actually exactly the same. If this is 38 degrees, this one is 38 degrees as well. Okay, so we're not going to do any work with the angle of depression out here. We're going to always move it to where we can use it inside our triangle right here. Okay, these are our steps for the word problems. We are going to draw a picture. Remember, please, when you're drawing a picture, guys, I'm going to really insist that you have a right angle in your picture and that your triangles are neat. Okay, so on purpose, make this perpendicular. Okay, so we draw a picture, then we label our part. So whatever angle we're dealing with, most of the time it will be this angle here, but I'm not going to discount that it's not this angle because it can be this angle. But you're going to label your parts like O, A, and H. And then we're going to use SOHCAHTOA. And we're going to solve using the 3 ways that we've learned. So what are the 3 ways that we've learned? We've learned, and I'm just going to give you an example. When X is on top, it's a multiplication problem. When X is on the bottom, move the trig to the bottom. It's a division problem. So this is a multiplication problem. This is a division problem. And then when X is over here, that is the inverse problem. And that's when we use the inverse key. Okay. So those are the only 3 types of problems that you have to do. Once you get the problem set up, then we have had enough practice with these. That's what you're going to be working on. Okay. Now, when we're doing these problems, you are doing 3 things in each problem. On your worksheet that we will do the next day that I see you, you're going to have the problem sectioned off like this. Okay, so in the first box, we're going to draw our picture. The second box is going to be where we set up the problem. And the third box is where we're going to write the answer. Okay, so I'm not going to draw these lines on all these problems, but those are the 3 things you're doing on your worksheet. All right, no matter what, you can start off with the same right triangle every single time. I haven't read the problem yet, but I know it's going to be a right triangle. Okay, so it says, a man flies a kite with a 100-foot string. So let's use a little bit of common sense. When we fly a kite, the kite is not directly above the man. The man is standing here. So this is 100 feet right here. Okay, the angle of elevation of the string to the kite is 52 degrees. So this is the first time we're seeing this word right here. And you need to know that in my triangle, the angle of elevation is down there from the ground up to the kite. And then how high off the ground is the kite? That would be over here. Okay, so you have to have an accurate picture in order to get credit for this answer, in order to get credit for this answer. So this would be opposite and hypotenuse. What uses O and H? At this point, if you know what you're doing, you can just pick up your calculator. You don't have to show me any work. If you know this is a multiplication problem, you don't have to write times 100 times 100 unless it helps you. I'll go ahead and write it just so you guys know what we're doing, but I'm just telling you that at this point, you can do this without showing me work. All right, this is what you're typing in your calculator. And we're going to try to remember to round to the tenths. And then if it's a degree, we're going to round to the whole number. And again, I'll give you credit as long as you know, if you round this to the tenths, it's fine, but I like angles to be whole number if it's an angle. So if I put this in my calculator, I'm going to say 100 sine 52. And I am going to make sure you guys are rounding correctly, so make sure you're paying attention. That's 78.8. 78.8. Technically, we're in word problems, so you should give me a word in your answer. Okay? All right, number 2. From the top of a vertical cliff. Okay, well, let's draw a triangle first. If you want to, let's just go ahead and do it, just so it looks like our homework. Okay, so here's my triangle. From the top of a vertical is up and down, cliff, 40 meters high. So this is 40. The angle of depression of an object that is level with the base of the cliff is 34 degrees. Guys, I don't care what all of that just said. I need this word and I need this number. When you see angle of depression, jump and find the number. This is what happen. This is what happens in my mind. The angle of depression, blah, 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 34 degrees. And I know because it said on the front that the angle of depression and angle of elevation are the same angle. That 34 goes here. How far is the object from the base of the cliff? So that means the object is here. How far is the object from the base of the cliff? So that means base is always the bottom. Base is always the bottom. So this is your X. How far is the object from the base of the cliff? Okay, so this is my opposite, and this is my adjacent. What uses O and A? Tangent 34 equals opposite over adjacent. Is this a multiplication or a division problem? It is a division problem. So if you know we're going to go 40 divided by 10, 34, you don't have to write that down. I'm good with that. But if you need to write it down, this is what it would look like. If X is on the bottom, move the trig to the bottom. If X is on the bottom, move the trig to the bottom. If X is on the bottom, move the trig to the bottom. This is what you're putting in your calculator. And so 40 divided by tangent 34, and we get 59.3 meters. Okay. All right, number 3. Haven't even read the problem, and I drew my triangle because I know I'm going to need it. Okay, an airplane takes off 200 feet in front of a 60-foot building. 60 and 200. At what angle of elevation? I stop right there. Angle of elevation, blah, 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 blah. I know the angle of elevation is right here, and we are assuming that the plane flies in a straight line once it leaves the ground. Okay, so we are using opposite and adjacent. Oh, by the way, in TRIG, tangent is used way more often than other trig functions, because you can have this measurement easily and you can have this measure easily and you can find other things in the triangle. So in the real world, they use tangent way more than they use the other ones. Okay, so this is going to be tangent of X equals opposite over adjacent. Okay, remember this is the switch. If you don't need to show the work, don't show the work, but this is what you're typing in your calculator. Okay, this is what you're typing in your calculator. Second tangent, 60 divided by 200. And we're going to raise that up to the nearest degree. Okay, so 17 degrees. You could put 16.7 or you could put 17 degrees. All right, number 4. All right, let's go ahead and label this problem, and I'm going to ask you a question about how you labeled it. And my question's going to be, I'm going to write this with pencil. Don't write this down, but I'm going to put a 1, a 2, a 3, a 4, and a 5. Okay, actually, you can write those down on your paper. And I'm going to ask you, after you set it up, and I'm going to ask you where you put something. Okay, 1, 2, 3, 4, or 5. Okay, go ahead and set it up. Okay, a 14-foot ladder, 14-foot ladder would be right here, is leaned against the wall at an angle of elevation of 68.2 degrees. So this is my 68.2 degrees right here at the angle of elevation. How far away from the base? What do I always say? The base is on the bottom, the base is on the bottom, the base is on the bottom. So how far away from the base of the wall will the ladder be placed? So my question that I asked you is, where was X? And X is in spot 2. Okay. So now let's work this out. So we're going to set this up. The next question I'm going to ask you is, will you use sine, cosine, or tangent? Okay, well, let's check it out. We have got adjacent and hypotenuse. So we are going to use cosine. So hopefully you got that right. Cosine of 68.2 equals adjacent over hypotenuse. And the next question I'm going to ask you is, what is the answer? Give me a decimal. Okay, so this is a multiplication problem, and we are going to go 14 times cosine of 68.2. And so your final answer should be 5.2, 5.2 feet. All right, question number 5. All right, let's do that again. Let's put 1, 2, 3, 4, 5. Go ahead and set up this problem, and I'm going to ask you a question about where you put everything to see if you got it right. Okay, the question was, compute the angle of depression. So your X should have been in number 4. Okay. All right, so let's set this up. So it says a person stands at the window of the building so that his eyes are 12.6 meters above the level ground. So he's standing here and his eyes are 12.6. And then, so this is going to be 12.6. Okay. And then it says, an object is on the ground 58.5 meters away. So that's going to be down here. 58.5 meters away from the building on a line directly beneath the person. Compute the angle of depression, which is this angle down here, of the person's line of sight to the object on the ground. Okay, so really in this problem, this is what we're doing. It's like this is a building, and there's a person in the building. And from his eyeballs down to the ground, 58 feet away, and that's a small number right there, but there's an object down here. Okay, so really what's happening is if he looked straight out, this is the angle of depression right here, but it's the same as this angle here because these are alternate interior angles. Just want to make sure you guys understand this is the true angle of depression, but it is equal to this angle right here. Okay, so we are using O and A, tangent, X equals opposite over adjacent. And the next question I'm going to ask you is, what is the answer? Okay, so this is the one where we do the switch. Now we have had this. This is why I asked this question. We have had this where I told you on the calculators, if you put this in the calculator using the ABC key, your calculator is going to get very, very angry at you. Let me show you. Okay, your calculator does not like decimals in the fraction key. So instead, you need to use the divided by key. So it's going to look like this. Second 10, 12.6 divided by 58.5. And we should get about 12 degrees. So if you put 12.2, or just 12 is what I had the answer rounding to, you are correct. All right. Go ahead and do number 6 all the way by yourself. Get the final answer. And I will tell you, it's in the hundreds, so it is a bigger answer. Okay, go ahead and do that problem for me. All right, here's what I got. So it said from the top of a 120-foot high tower, so from the top of a tower, the angle of depression is 19 degrees. So we know by now that's down here. And the angle of elevation and the angle of depression, they're both in the same spot. How far from the base? What do I always say? The base is on the bottom. The base is on the bottom. The base is on the bottom. And so the base is down here. So how far? That's your x. So again, this is opposite and adjacent off of this angle. So tangent of 19 is 120 over x. This is a division problem. So we, if x is on the bottom, move the trig to the bottom, and we put this in our calculator, and you get 348.5 feet. Okay, we're done with the video notes. If you will go in and mark them as done, please, to get them off of your to-do list. And then the worksheet you're going to have only has 10 problems on it. If you want to go ahead and get it done, you can, and then you can use class time to work ahead on other things. Thanks, students.